In this video we will talk about expansion of functions. So if we're talking about a general function f of x, so a series of this function will be a naught a1x plus a2x squared plus a3x cube and so on, where a0, a1, a2, a3 and so on to an all are the coefficients, and x, x squared, x cube all are variables of this function. In order to find the value of the coefficients a0, a1, a2 and a3 and so on, the successive derivative come into play. As if I'm interested in finding the value of a0, then by putting x is equal to 0, then I will get f of 0 is equal to a0, because all of the elements other than a0 will eliminate when x will be 0. So the value of a0 will come out. But while talking about the values of other coefficients a1, a2 and a3, then taking derivative will be helpful in finding the values of all of the other coefficients. That is, if I'll take the derivative, the first derivative of this expansion, it will be the derivative of a0, that is a constant, is 0. Then derivative of a1x, where a1 is a constant and dx by dx is 1, will be a1. And then derivative of a2x squared will be 2a2x, because of the power rule. 2 comes down, there is a decrease in the power, 2 minus 1, and 2a is 2x. And then the derivative of a3x cube will be 3a3x squared and so on. And then the nth term, the derivative will be n x to the power n minus 1. So well, x is equal to 0, so f dash of 0 is equal to a1, because all of the values eliminate when x is equal to 0, and we only left out with a1 is equal to f dash of 0, the first derivative at 0. So taking the second derivative, we will get a1 is a constant, derivative of 0, and then 2a2x derivative will be 2a2, and by applying the power rule as same as we did earlier. So by putting x is equal to 0, we will get f double derivative of at 0 is equal to 2a2, and all of the other elements will eliminate while putting x is equal to 0. So the value of a2 will be f double prime at 0 by 2. So this is the value of a2, this is the value of a1, this is the value of a0. And then we will find the value of a cube by taking the third derivative and letting x is equal to 0. Then we will get a cube is equal to f third derivative at 0 by 6, because we know at this stage by taking third derivative x dx by dx is 1, and we only left out with this thing 6a3. So by taking out the value of a3, f triple prime of 0 third derivative at 0 by 6. So this is the third derivative, and by countering these all the values of a0, a1, a2 and a3, we can write the nth term or the nth derivative or the value of an by countering all of these values. That is, nth value of, or the nth coefficient is the nth derivative at 0 by n factorial. Because of this, it can be 2 can be written as 2 factorial, and 6 can be written as 3 factorial, that is 3 into 2 into 1. So nth value is nth derivative at 0 divided by the n factorial. So putting back these values of the coefficients in the series of expansion, so we will get substituting the values of the coefficients in the power series, then we will have this type of series that f of x is equal to f of 0 plus the first derivative at 0 with x, and the second derivative at 0 by 2 factorial into x squared, and then add the same thing. So this expression is known as Maclaurin series. As we expand the function about x is equal to 0, so we have an expansion of this type, and it's also known as Maclaurin's theorem. Now let's see how we can use Maclaurin series in solving problems. Maclaurin series or Maclaurin theorem are used to expand any function about 0. So I'll take a function, exponential function e to the power x, because it is really important and very common function. So the very first thing in solving or expanding this function is, first of all, I will write f of x is equal to e to the power x. Then the value of f of 0, the value of x, e to the power 0, which is equal to 1. Then taking the first derivative of this function will be e to the power x, and the first derivative at 0 will be again 1. So because all of the derivatives of exponential function will be e to the power x, so f to the nth derivative is also e to the power x, and so on, and which means that the values of the function, the values of the derivative of the function at 0 will also be 1. Now we have to putting such values in the general expansion formula, that in general Maclaurin series, because f of 0 is 1, and f dash of 0 is also 1 with x, and f of 2 at 0 is also 1 and 2 factorial. So let's putting the values in this series. So after putting values, we have the general form e to the x, because the function is e to the x, expansion function. F of 0, that function at 0 is equal to 1, and all of the derivative at 0 is 1, so x plus x squared by 2 factorial, x cubed by 3 factorial, and so on, x to the power n by n factorial. This is how we can expand any function by using the Maclaurin series. So in the next video we will talk about a general expansion formula, that how we can expand any function other than 0, because in Maclaurin series we expand the function about 0. So in the next video we will talk about it generally. So stay tuned. Goodbye.